remind numbers are numbers that can be written as a fraction, like a over b, where a and b are integers with no common factors. The reason that's important, we're going to talk about rational exponents today, and we don't want to get wrapped up in what the rational means. We want to make sure we just are focusing on the exponent part of it. So our lesson 7.4 I can today is simplify expressions with rational exponents. Simplify expressions with rational exponents. And we learn how to write exponents as rational numbers. Moving on. There's a bunch of rules they gave us on page 381, properties of exponents. Well, they're all reminders, okay? Because you've seen these before in algebra. But now they apply to rational exponents, but they're all the same rules. So the first thing I want to do is walk you through some examples of how we're going to write these as rational exponents. And the first case, I'm going to write this as the square root of 3 squared. Okay? And then I'm going to rewrite it as a rational exponent. So this is 3 squared, and the square root means the 1/2 power. Okay? Square root means 1/2 power. So if they just ask me to write it with a rational exponent, I might stop here. But if they ask me to simplify, then I would say, remember the rule when you're raising a power to power, you multiply the exponents? And so what's 2 times 1/2? 1. So this simplifies into 3. And I know this is a long ways to go when you could have looked at the first one and said, well, the square root of 9 is 3. I know that. Okay, I know you know that. I'm not asking you to do this on every problem. I just want to walk you through what's really happening here and show you how it's the same as what you already knew. Okay? And so down here, we're going to rewrite this as cube root of 2 cubed, because 2 cubed is equal to what? 8. And so then we already have this written out for you. Cube root of 8 is equal to the cube root of 2 cubed, which is equal to 2 cubed to the 1/3. And again, if they ask us to simplify, that would be 2 to the 3 times 1. Yeah, 2 to the 3 times 1/3, which is 2 to the 1. Okay? All right. Not a lot of discovery going on today. I'm just going to show you the facts, give you some time to practice the facts, and then tomorrow we're going to learn how to solve equations with these radical and rational exponents. I know that's kind of overkill. You can use your calculator to find the cube root of 8 is 2. But I want to make sure you understand the relationship between these radical signs and rational exponents. Any questions on that before we move down to this other example? How can I rewrite this one then as a rational exponent? I'm going to write this with a rational exponent. What's that?
X to the 1/5 power.
Yeah, remember if it's a root of 5, then I'm going to write it as 1/5 as an exponent. And so this number is x, and this power then is going to be 1/5. And so the 5th root of x means x to the 1/5 power. Okay? our rule that we're using here says if the nth root of a is a real number and m is an integer, then a to the 1 over n is equal to the nth root of a, and a to the m over n is equal to the nth root of a to the m, or you could write it as nth root of a all raised to the m power. And here's the key we have to remember. If m is negative, then a cannot equal 0. Because remember what negative exponents do? 3 to the negative 2, what is that? Well, let's copy this down and I'll ask that question again. So this example right here matches this rule. And so if I want to write it as a rational exponent instead of a radical sign, rational exponent, it would be x to the what power? What's that? 5 over 4. And our little reminder here, the index of the radical is always the denominator of the fractional exponent. I added a couple words in there. Index of the denominator is always, the index is always the denominator of the fraction. Meaning the index of the radical sign, this number here, is always the denominator in our fractional exponent. Okay, always. So someone other than Matt, how do I write this next one? Well, x to the, you said x3 to the 5th. I think you just put your 2 in the wrong place. X to the what? What power? 3/5 power, yeah. I think you meant to say x to the 3/5. You said x 3 to the 5th or something. It's, whatever. It doesn't matter. So we get x to the 3/5. Again, the index becomes the denominator, and the power becomes the numerator. Okay? Any questions on that? All we're doing is practicing rewriting them. So we understand how to change them back and forth. Just set that on my desk. Acquaintance, why don't you set that on my desk? All we're doing is practicing writing them as from a radical sign to a rational exponent. Okay? Okay, write the exponent in radical form. X to the 2/7, I want to write it as a radical now. So I'll go the other way. What do you think, Caleb? Number 1 here, how do I rewrite that with a radical?
Would be square root sign, 7 as the index.
7 is the index, so you mean the 7th root sign.
Right.
Okay?
And then x squared.
Sure. Or, how else could I write that? Liberty? So 7th root. Ah, good. Exactly. So if I wanted to, I could put the square, the power, the squared, outside. Okay? So I could do that. So either way, typically I write it this way and I don't have to show parentheses. But I'm not saying it's wrong, I'm not saying it's better to do it my way, I'm just saying that you can do either way. Okay? This one's a little tricky because it's a decimal. And we're talking about rational exponents. So the first thing we might have to do is rewrite this instead of a decimal as a fraction. So what is 0.4 as a fraction? 2/5. It's 4/10, right? 0.4 equals 4/10. And if you reduce that, you get 2/5. And so we get negative 2/5. Think now. It's tricky. Just throwing something else in we haven't done yet today again. You've done it before, but not today. Natalie, what would you do if that negative sign wasn't there? So I'd write, what's that called if I put the 5 as the index? Louder? What was it called right here? What's this symbol? 7th root. So if I put the 5 as the index, it's called what? The 5th root. So 5th root of y squared. Well, what if I did this? Do I still have my negative? I do. So that might be the easiest way to deal with that. Put that negative out there, and now I can deal with the negative. What does it mean to be a negative exponent? This is what I asked earlier, and you were in the middle of copying. Yeah, Noah? What's that? It could decrease, but it could increase too. I'm not sure. You might be thinking correctly, just not saying it correctly. I'm not sure. What did you say? No? It doesn't mean the numbers are negative. Doesn't even mean odd. What does a negative exponent mean to do? If I have, let's put a simple number here, 2 to the negative 1. What's that equal to?
It's 1 over 2 to the first power, or 1/2.
Yeah, it's 1 over 2 to the first power. What is 2 to the negative 3 equal to? 1 over
Ms. Clairday, please report to the office.
2 to the
Ms.
third
Clairday,
power.
please report to the office.
Okay? So the negative exponent simply means what? What's that R word that represents this? Reciprocal. Okay? All negative exponents mean is reciprocal. It doesn't make the number negative, doesn't make it odd, doesn't make it bigger or smaller. Well, it might, but there's no pattern to it. If I took a fraction and like 2/3, what the heck? Oh, so this won't probably 2/3 to the negative 1, okay? That's going to mean reciprocal. It means 1 over 2/3 to the positive 1, which means 3 over 2 means reciprocal. And you can jump straight to that. You don't have to throw in that middle step, okay? It means flip it over. So in this case, it went from 2/3 to 3, 2/3 to 3/2, it got bigger. But if I have 5/4 to the negative 1, then that's going to be 4/5. Now it's getting smaller. So the point is, there's no real pattern to that. The pattern is that we're taking the reciprocal of it. So if we go back to this, how am I going to write that then? What do you think, Mason? 5th root of y squared to the negative 1. How am I going to write that without the negative 1 exponent? So how do I write the reciprocal? That's what I'm asking you. Tell me what to write.
Would you just switch to
No. No, it's, the negative is not really on this number, it's really on this number. Okay? If I flip that 2 and 5 around, then I get a totally different answer. Because now I'm talking about the square root of y to the 5th. That's a lot different than the 5th root of y squared to the negative 1. What do you think, Judy?
1 over the 5th root of y squared.
Yeah. Reciprocal means flip it over. If this is in the top, I'm going to move it to the bottom. If I have to put a 1 on top, then that's what I do. And so I get 1 over 5th root of y squared. Okay? 1 over 5th root of y squared. Write in simplest form. And in red there, I've reminded you of a rule that we've learned. By the way, all these rules I'm implying here are on page 381. There's a box on the top of page 381 with all these rules in there. If you don't remember them, you should turn to that page and copy them down. If you remember them, then don't waste your time copying them down. They are reviewed. Natalie?
What page did you say?
381. So without telling me the final answer, can anybody tell me what I might do as a first step? And understand there's lots of steps we could take. There's way more than one way to do any of these problems. So what might I do on the first step? Noah, you've been really quiet. Can you help me with this one? What might we do? Try on the first step.
Put both of those over or under 4. Or not. No. Never mind. Put them under 1 and then I don't know.
You're saying deal with the negative 4 exponent?
Yeah.
Okay, and that could work. I mean, you could absolutely get there doing that first. You really could. He's saying, I'm going to write this as 1 over x to the 2/3, y to the negative 1/4, negative 4. I'm sorry, positive 4 now. Okay? He's saying to do this, and you certainly could do that. But when I look at what's inside the parentheses, what else do I see?
Another negative.
Another negative exponent, don't I? Which can create some problems. So probably,
Oh, you wouldn't do it?
probably I wouldn't do that first, although it certainly can be done. I probably would say let's use that rule over here first.
Can we cancel
I
out?
have this to the nth power, and so I can put that power to each of these. Okay? And it's multiplying. It was a 1 and a 1, and now it's n and n, so it's 1 times n. And so I'm going to raise both of these exponents to that power right there. Okay? And so this is x to the 2/3 times negative 4 over 1, y to the negative 1/4 over, or times negative 4 over 1. And so what do I get in this case? X to the what? I'll give you a hint. It's a negative.
Negative 8/3.
What's that?
Negative 8/3.
8/3. No common factors here, so we just multiply straight across. 2 times 4 is 8. 3 times 1 is 3, so I get 8 thirds, negative 8/3. Y, someone other than Jade, how do I multiply negative 1/4 of negative 4/1?
Cross kids.
Louder?
Cross kids.
Okay, so what do I get?
1. Like.
1.
Do
Positive
we
1,
necessarily,
doesn't it?
do we necessarily have to show that it's 1, or can we just put 1? Y?
You can leave it as Y.
Okay.
We have another step we have to do, and so by putting it there, you're emphasizing, I know this is a 1. It's not, I accidentally forgot it, I know it, okay? But you wouldn't have to. I wouldn't mark it wrong if that wasn't there. For sure would not, I would not mark it wrong. Now, if I didn't do what Noah did right away, I have to deal with it now. I still have a negative exponent, don't I? And so where does that go? Someone started to say something, and someone coughed. I couldn't hear you. What do you think, Devin? Where does that 8x to 8/3 go?
I don't know. Under 1?
Okay, I could. Does this go down also?
No.
No, so let's leave that up.
Over Y? Under Y?
Yeah, and then let's move this down underneath that. And so now, once you move it from top to bottom or bottom to top, you change negative to a positive. Okay? Now, I think this question in simplest form means as a radical. Okay? So if I wanted to leave this as a radical instead of as a rational exponent, what would my last step be? What do you think, Liz?
Square cube root of x to the 8
Okay?
over y's over.
And underneath the y. Okay, good, I agree with that. So that would be my final answer. Y over cube root of x to the 8. Okay? Quite a few steps we took to get there, but that's because you just started. You just remembering what we're doing. So we took 1, 2, 3, 4 steps. Probably taking Noah's route, we would end up with 4 steps also. All I did in doing it this way is I reserved moving things up and down because of negative exponents until I knew exactly which ones were negative and which ones weren't. So you move this down and you're going to turn around and move this one back up. Right? Which is okay. You still probably took 4 steps. And it's not wrong to do it that way. There's so many different ways you could do these problems. And usually when you ask me, if you get hung up, I'll say, well, this means this, and this means this, and you tell me which one you want to deal with first. Because you just have to develop a preference on how you do it. Rarely is one method any more right or any easier to use than another. And I really don't even think that my method over what Noah started me on was any easier either. Everything still had to be dealt with. I just try not to move down and then up and then down, keep moving things up and down. I try to do that all at once. And because I saw that negative sign inside, and I saw a negative outside, I knew I'd have to move things a couple times if I didn't do it first, or deal with this other first. Okay? Any questions on that example? Okay, moving on then. There we go. That's all the examples we have. Let me say this. Your assignment is going to be 3 to 48 by 3s. Lesson 7-4, 3 to 48 by 3s. How many problems is that? 16. Very good. Now, I want you to glance at them, and if you see any non-multiples of 3 that look scary to you, like I haven't covered it well enough and you'd like to see another example, speak up and call out that number and I'll do that for you. Okay, so look at numbers 1 to 48 And if you see any of those that you just look at it and say, hey, you didn't do one like this, then let me know and we'll do one. All right? I'll pause while you look. So number 26, someone asked for 26. It was H equals .00, just 2 zeros? 252 D to the 2 point, was it 27? Over E. You need to make sure I copy the problem right. And then they're telling us D is 100 and E is 1.2. So they're saying just calculate this. Oh, and I didn't get the calculators out, but when you throw those into the calculator, it will give you the answer. So you really don't have to know much about rational exponents here. They just want you to know how to use that formula.
Do
Okay?
we have to know that formula like for a test or
No.
anything?
No, I'm not asking you to remember that formula.